All right, this is lesson 5.2, and the topic is called Ways to Prove that Quadrilaterals are Parallelograms. Just to review what we've already had, in the last section we talked about what a parallelogram was. Now by definition, a parallelogram is a four-sided figure, or a quadrilateral, where both pairs of opposite sides are parallel. So it's kind of like a leaning rectangle. And that's all you have to have for a parallelogram. So in this one, this would be one pair of opposite sides, and they need to be parallel if it's a parallelogram. And then the other pair would be these, where I have the arrows, the two sets of arrows. So if both pairs of opposite sides are parallel, that's all we need for a parallelogram. Now we also went into some theorems. If you have a parallelogram, or some things that do happen. One thing we talked about, or one theorem, was that the opposite sides are equal in length. So that pair of opposite sides would have to be equal in length, as is this pair of opposite sides would have to be equal in length. Also, we said that the opposite angles are equal. So those angles, that pair of angles would have to have equal measures, as would this pair of angles. They would have to have equal measure. Another thing that we talked about is that the diagonals have a certain relationship. So if I have the diagonals bisect each other, so this diagonal is going to cut this diagonal into half. So really what we're saying though is that since these diagonals are bisecting or cutting each other into equal parts, so this part equals this part, and then these parts are equal to one another. And that's where we left off with the first section in this chapter. Now, I want you to write down this theorem. Okay, and this theorem says, if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Now, what we're trying to do in this section is that we're not sure if we have a parallelogram. So now we're kind of going at it from the other side of the situation here. So I'm going to go back a screen here. We want to, if we have a four-sided figure, what we're trying to do is we want to show that it's a parallelogram. Now one way to show it's a parallelogram is if both pairs of opposite sides are congruent, that four-sided figure has to be a parallelogram. Now in the figure that I have here, if I'm able to take this four-sided figure, this quad ABCD, and if I know that these sides are equal and these sides are equal, you know what? It's got to be a parallelogram. That is one way I can show that this four-sided figure or this quadrilateral is a parallelogram. Copy this theorem down. It says if one pair of opposite sides of the quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So in other words, here I don't have to show that both pairs of sides are congruent and parallel, just one. So what this is saying is, say we're talking about this pair of sides. Now if this pair of sides are equal and parallel, you know what? Quadrilateral ABCD is a parallelogram. Or, I'll just put this in a different color, or if this pair of sides are equal and parallel, it's a parallelogram. Okay, theorem 5.6, copy this one down. If both pairs of opposite angles are congruent, then the quadrilateral has to be a parallelogram. So in this, if I know that this pair, if these angles are equal, okay, they're opposite angles, if they're congruent, and if this pair are congruent, it's got to be a parallelogram. And finally, copy down theorem 5.7. If the diagonals of a quadrilateral bisect each other, so in other words, if we have a four-sided figure and we find out that they cut each other into two equal parts, so AC is cut into two equal parts like that, and DB is cut into two equal parts like this, it's got to be a parallelogram. So 5 ways to prove that a quadrilateral is a parallelogram. And I want you to write these down in your notes. So we said if both pairs of opposite sides are parallel, it's a parallelogram. And that's really one that we didn't have as a theorem, but that's just the definition of a parallelogram. So in other words, if you have a 4-sided figure and you know that both pairs of opposite sides are parallel, it's a parallelogram. Number 2, if both pairs of opposite sides are congruent, it's a parallelogram. Number 3, if one pair of opposite sides are congruent and parallel, it's a parallelogram. If both pairs of opposite angles are congruent, it's got to be a parallelogram. And finally, number 5, if the diagonals bisect each other, it has to be a parallelogram. All right, let's take a look at maybe just a couple basic examples. And let's see here. It says, study the markings on each figure and decide whether ABCD, or in other words, quadrilateral ABCD, must be a parallelogram. So let's take a look at number 1 here. Make this a little bigger. All right, at number 1, all right, let's see what I have. Now, first thing I notice is that the opposite sides are equal. So this side is equal to this side, and this is equal to this. You know what? And that's one of the 5 ways to determine that I've got a parallelogram. So number 1, yes, this definitely has to be a parallelogram because both pairs of opposite sides are equal. Okay, let's take a look at number 2. Now, number 2, let's see what we have. We have one pair of sides that are parallel and they're equal because both of them are 9. So if I go back to my 5 ways, and I'm not going to magnify that back again, but one of your theorems said if one pair of sides are parallel and congruent, it's got to be a parallelogram. So number 2 is a yes, that's got to be a parallelogram. I'm not going to go through all these, but just to kind of give you a feel of what this section's about. Let's take a look at number 3. All right, number 3, I noticed that one of the diagonals are cut into 2 equal parts. That doesn't necessarily mean the other one is. So let's see, do I have any of those 5 ways? It looks like I have one pair of sides that are equal. I have a diagonal that's cut into 2 equal parts, but not both the diagonals. I'm just looking to see if there's any other combinations that we have. Let's see. I don't believe there is. Okay, so what I have here, this would probably be a no because we don't have enough information to say that it's going to be a parallelogram for sure. If you look at number 5 here, I'm not going to move. I'm not going to look at number 4, but number 5 is showing there. You have one pair of opposite sides parallel, or you have one pair of opposite angles parallel, don't we? Both of them are 70 degrees. Again, that would be a no because we would have to have both pairs of opposite angles equal in order for us to have a parallelogram. All right, so that kind of gives you a feel of this section. And again, this is ways to prove that that you can have a parallelogram.